Hey, welcome back everybody. Hope you all had a wonderful holiday, good Christmas, got everything you wanted. I'm here in the shop this week. We got the new heater running today. So far it's 21 degrees. So in here we're about 60 degrees, which is plenty comfortable. Just a couple updates. Yesterday I knocked out this mountain bike here. Re-welded. This was a broken wheel hub bracket, I guess. This is all carbon fiber here, and this is sleeved, 6061 sleeved. This looks like this might be glued and riveted. This was a real pain, I'm not gonna lie. I don't know if we weakened the structure of the carbon fiber, but I tried my best to keep the heat out of it. Welded a little bit at a time, but welding casts, sometimes you just got to get heat into it before it's really going to do anything. So, but I put it all back together, test rode it. It seems like it's fine. So hopefully the customer will have some good luck with it. He also had some previous damage here on his frame that he went ahead and put some carbon fiber mat on. So he wasn't too concerned of whether or not this was going to be a problem or if it would break in the future. So we risked it. We went at it, and it seems to be okay. Another thing that we accomplished yesterday is we got this ZX12 frame re-welded. This tab that he broke off, so we were able to weld this cast here. Not any huge issues. Welded real nice. Generally, motorcycle castings seem to be really nice. They must use pure aluminum or something. I've never had any problems welding it, whether it be a motor or a frame. It usually seems to always be just wonderful to weld, where you can't really say that about other casts. Even on this Cannondale, this wasn't that great to weld, and that's cast too. That wasn't actually a machine part. You think they would machine that, but no, that's cast. Well, I got that all done. I got the outside insulated and a plate, just like a matching plate there to cover the brick that we knocked out. Now I'm working on putting in this protected grate to keep you know, birds from flying in. This will go over the outside porch so there's not just a big huge hole. It'll also help keep water and small rodents and things like that from getting in there. It's a pretty big port. It's 12 inches, so we're going to go ahead and cut this stainless steel out, and then we'll go ahead and put that up there. Hopefully, I mean, when I originally fired this up, I didn't have the exhaust port run. I just went to see, and man, it kicked some serious heat then, but you know, a lot of that was of course going to be the carbon monoxide and whatnot off. So I'm hoping that we could maybe bring some more BTU back down into this by slowing down the airflow a little bit, because basically how that heater works is the flame grids on the bottom heats up those panels, and then the flame goes back out. But you can see that big open port there is also an airflow that comes through, and that goes up through the exhaust, and then there's a port in the middle that the flame burns up through. So what we're pulling in, and we have a lot of airflow there, we're pulling in a lot. I'm hoping that if we slow that down a little bit, we'll be able to keep a little bit more heat here. Maybe the panels will get a little hotter. It does a good job, but it was definitely noticeably different. It was a lot warmer without the exhaust port on. But generally, those heaters are about 80% efficient, so 20% of the heat should be actually going out there. But it's a considerable amount of heat that's being pumped out there. Yeah, it's a pretty nice view from up here. So here's the exhaust that we did. I used all stainless steel, 304. This is just galvanized sheet that I had. I had a sheet left over from when I built the big oven. So I decided to use that because it was a lot cheaper and I already had it than using a full sheet. That was basically a full sheet, 4x8 sheet that I ended up rolling because it takes about 38 inches. And we got about 8 foot of pipe in there, plus my 90-degree bend. We got the grill that's stainless, that's made to keep the birds from flying in. Stainless on the wall. On the inside wall, I just used regular steel because that's not going to be exposed to the elements. We did some fire stop putty here to seal off the break there, which was very minimal, but I wanted it anyways. Help keep bugs and things like that out. Nesting in the wall. And then we just basically screwed and lagged it to the wall. That's it, 12-inch pipe. Moves a lot of air. Woo. Boat from the 50s. This whole back area here is going to get cleaned up. As soon as they can get that van out of there and finish the siding that they started over here. I'm going to come in here and finish this up. Ideally, I'd like to put a fence up and close it, at least for the dogs, and also to have a little bit more secure storage area. Susquehanna River looks like it's starting to freeze up. It was about 21 degrees today. I'm not sure what it's at now, probably like 25, 26. I have the Haimer here that I've been using to dial in my work offsets. A little bit ago I picked up this Hallmark ITTP. It's a touch probe made by Cliff out of New Zealand in his small little workshop. I don't know if you guys have followed along. He documents his whole entire build over the last year in design, prototyping of these things without actually showing you how they work. They are now available from him. I just set this up to test how good the calibration was on the probe, and I just took maybe 5 minutes to set up the probe here in PathPilot compared to the Haimer. I'm going to go ahead and regenerate the test. I'm going to recalibrate my zeros and show you how close they are. But I essentially got, in Z, I got 1,000th difference between the Haimer and the probe. I'm going to go ahead and give that one to the probe due to the nature of setting the Z0 on this is a little finicky, and it's kind of a mechanical way to do it. This is much more accurate. Now when you go to your X and Y, you're just setting off the probe, so once you dial in the width of that probe and the offset of that, it should be relatively close. And the measurements that I got were X was spot on perfect and Y was off by half a micron, which, hey, you know, I'll take it. And that's with making sure that you have to dial this in, get that zero just perfect. And it's a little hard to do. It's much easier with the probe. The probe just touches off, senses it, and calibrates it. This is kind of has a little bit of user error factored in. So I'm going to go ahead and I'm going to set up the Hallmark here. I'm going to run find the XY0 here and the Z0. And then I'm going to go back with the Haimer and verify with the settings I have for the Haimer. In all fairness though, I haven't calibrated the Haimer since the last time I broke a tip. So we'll see if we can get within the same measurements that I originally got. Alright, so we're going to do the find rectangle boss center. So we want to find the center of this rectangular shape. And I'm using a 1, 2, 3 block, so we got 1 inch, 2 inch, and it's 3 inch high. But that doesn't matter. We're just going to set the X, Y, and then Z off the top of this. So we're going to use the probe setup first. All we have to do to set the XY0 on this is basically find the center, set work origin. So I just hit that, and this thing will run a routine. where it finds the general outline of what kind of shape we're dealing with. So there it knows that it was at the edge of the part. So it's probing that edge of the part. Didn't find it, so now it knows it's at the end. Now it's going to go back and do a more accurate calibration where it's going to find the centers. Okay, so there it found my and set my coordinates for my X and Y 0. So if we come over here and we look at the main screen, we're going to have our X and Y zeros are just set. So what I'm going to do is I'm going to now go up here on my Z. I'm going to tell it to go to G0, Y0, X0. And it puts it straight over that centerpiece. So I'm just going to take my Y, move it forward a little bit so that we can drop down and hit make contact there. I'll go back into my probe routine. I'm going to go ahead and I'm going to find my Z, set my Z. So we'll hit that. It's coming down and finding Z. So there we go. That was it. So now I have my X, Y, and Z 0 set to the top. Z is set to the top of this, and X, Y is set to the center. So now we can go back and we can verify with the Haimer and see how accurate we are. Okay, we have the Haimer in. Now we have to go over here and set our tool from 99 to 98. That's what I have my Haimer set for. You can see the offsets here. 98 is the Haimer and 99 is the ITTP Probe. So we're going to go ahead and check where we are here. So we should still be at Z. So I'm going to go ahead and dial this in for Z. 2 rotations. And then go back. Take out our backlash. There we go. We're set on 0 according to that. And it's showing us our Z is 6 microns. So that's how far we're 6 microns below. So about half a thou difference between the Haimer, which is mechanical, you just dial in your 0, and I dialed out the backlash, compared to the Hallmark ITTP Probe. So that looks pretty good there. That's, for anything I machine, that's plenty accurate. Alright, so now we know we're in dead center. I'm going to go ahead over here and check my X. Go down here. I'm going to go X over. So this should be at -1 inch. Go past a little bit and then backlash out. We're on 0 there. And we are set at exactly -1 inch. With my backlash worked out. So that would mean that at 0 we'd be at the dead center of this part. So we're going to go to a +1 inch, and that's where we should be there. So I'm going to go ahead and go up. I'm going to go over this way. Go down. We should hit 1 inch. Backlash now, forward lash, and we are at 1.008 microns. And if we took a little bit more out, the backlash that way, we're right on there. So we're actually right on when I did the backlash the opposite way because I'm on the other side. So that X is dead on 0. Compared to what that found and what that set up. I was able to double verify that on the x-axis. Now let's try the y. Go up. We go to x0. That should be dead center. Now we're just going to go ahead and set the y. Should be half an inch. Okay, that should be there. It'll show me 0.05009, so 9 microns, so almost 1 thou. We double check our backlash. That puts us in within 1 micron. So that's pretty accurate there. I'll take that as well. We'll take our Z up and we'll check the other side. We should be at -5. Back, creep up on it, and back. Okay, that's pretty close there. We're at 6 microns. So let's check this again. Seven microns. So we're a little bit out there, 7 microns. But still well within tolerance. If we actually go back the other way and hit it there, we're off 2 microns. So within 1, we're 1 micron over here, 2 microns over here, which is about 1 micron off on the Y on this distance. And that could be a number of things. But still, this is way quicker to use and set up than using this. And this is all subjective on how well you check your backlash, because this will automatically factor into backlash because it goes in and comes back out and it sets it again. This is also depicted on how well you see your up and down arrow or your needle on the 0. Also, when you calibrate this needle here, you got to dial it in and make sure it's centered. And so that's also a factor on the 0. So there's room for errors with this, but the Haimer is probably one of the easiest and quickest ones to manually do. And by far, this Haimer ITTP has proven to be extremely accurate just after setting it up right out of the box. So, Cliff, you made a really nice product, bud. Really impressed. I've been waiting to get this thing up and in here, just haven't had time. So today it was, let's get this probe working and let's get version 2.0 loaded, which we did. I don't know if you can see that. Which is a complete rework. I like that it has bigger buttons here. That's a lot easier to slide than the little ones with the touchscreen. Not sure all what this revision has in it, but I'm sure I'll find out. Well, that wraps it up for today. Got the things done that I wanted to get done over there with the probe, the vent, just finishing up loose ends. Got some lights hung in here. I want to wire them up tomorrow and wire them into the switch and into the breaker panel. So then we'll have light in here. I had one piece of plywood sitting around. I'm waiting for a truck so I can go get I need 12 more pieces. We're gonna do the inside and the outside, all the base with plywood so that it's durable and we're not gonna have to worry about anything knocking into it like a forklift or if we're sandblasting. And then up there it gets about 3 sheets and a little bit of a 4 sheet.
What are you looking at for, birds?
That is all I have for today. Thanks for tuning in. Feel free to check back. We'll have some more stuff going on. I got some other projects I got to get to. kind of sitting in a holding pattern on a couple of them because I have to do a little bit more research. I did want to start machining today that cramp-on adapter, but I just kind of ran out of time, and Dan showed up, so I had him help me hang those lights because it's kind of hard to do by yourself. So I might start that tomorrow. If not, I'm definitely doing the wiring in there. I have this belt 2x72 inch belt sander I got to do. I gotta go over these plans here this guy gave me because it's pretty complex. It's not just whip it up and go. Check out the YouTube video, see if there's a better way to do some things, but that's about it for today. These guys want to go home, but on a positive note, the heater's been working fantastic. It's 65 degrees in here. I'm completely comfortable. It's warmer than the office, and the office has electric heaters. And yeah, happy about that. I changed my fans around to pull up. That's what you're supposed to do for winter, and run them on low, and that seemed to really make a big difference. So I'm out of here for the day. Hope you enjoyed. If you did, subscribe, tell your friends, tune in next time. See ya.